Hey, hello everyone. Thanks for joining and tuning into today's Code Power session. I'm Michael. I work at VMware. I'm a staff engineer at VMware in the office of the CTO. And today we're going to cover Git, practical Git. Git for everyone is the subtitle here because I want to make sure that we, like everyone joining here or watching the recording later, that you get a good understanding or maybe better understanding, depending on your current knowledge around Git itself, core Git. And we'll have a couple of demos, and hopefully we'll also have time to cover another topic, which is dear to my heart, which is workflows using GitHub Actions. All right, let's dive in because we've got a lot of things to cover today. So there's going to be two parts. Part one is going through Git and hopefully getting everyone excited about Git. Or if you're more like an advanced user on Git, maybe there's something that you also get out of this talk here. And part two, as I already mentioned, will be GitHub Actions. And if you haven't heard about GitHub Actions, it's actually a workflow engine from GitHub, which is very, very useful to do like amazing things. Okay, let's quickly start with some slides on Git. And I think, especially most of you, if you're new to Git or like just starting with Git, or you're planning to use Git for a couple of reasons, you might be overwhelmed with all the different terminology that you might come across using Git or any of these platforms like GitHub or GitLab, or reading blog posts. So there's a lot of words which probably don't even make sense, or even after starting with Git. And so especially when you contribute to projects or you have your own project, then new terms will come up and people will going to ask you, shall I rebase? Or, what about squashing? And how is it actually, does it work to contribute to your project, et cetera, et cetera. So I want to make sure that in this session today, you get a better understanding of Git, some of the fundamentals. We'll not use any fancy UI for dealing with Git, because I think, and that's also how I learned, if you understand the basics, the essence of Git, especially through the command line, you can then later use a UI in a much better way, and also like prevent some harm that you could potentially make using a UI, especially when you're dealing in larger projects, shared projects, etc. Because UIs are not always clear there, or might not always give you options to perform specific actions. And also, something that is dear to my heart is that a lot of people think that Git is probably just for developers, and especially for the people that I interact with on the open source projects that I work on. It's often hard for them to understand what we mean when they are contributing to our project. And that leads to the problem that people might be afraid of contributing, and we don't have contributors there, but we want to grow a community around our open source project. So we want to make sure, or I want to make sure that everyone can use Git and can contribute to open source projects, and not ends up like Patrick here, basically closing his pull requests and saying, I'm just fixing the mess with another pull request because I don't know how to fix the mess that I created with this pull request. Yeah, and this kind of comment yesterday that Ryan sent me, my colleague of mine, basically is kind of on point. You have no idea, just memorize these shell commands and type them to sync up. If you get errors, save your work elsewhere, delete the project, and download a fresh copy. And I want to make sure that you get more familiar with these tools by understanding the basics of Git, so you don't have to be afraid of some kind of, maybe not even warnings, but some text that this Git gets back to you. And Git is very helpful. Git tries to help you when it gives you this messages, basically, when certain things occur and you need to work them out. Git is very helpful, but the terminology can be confusing, and so people get afraid and like, oh, I don't know what I'm doing here. Let's just screw it. I'll move on. And we don't want that. So, what I think Git should be for everyone, and I want to give you a couple of reasons why, even if you're a non-developer, like your daily job is not writing software, writing code, even for your work as an administrator, operator, or whatever role you're working in, Git can be useful as well. So let's assume you kind of have these daily tasks or routine here, where you maybe have some scripts to perform some automation or tasks, or you do it dealing with configuration files to configure, I don't know, Terraform resources or Kubernetes clusters or other environments. or you want to save your Linux environments. You have a nice terminal set up, or on Mac or on Windows, everything is nicely set up, and you want to make sure that you save all these configuration files somewhere, and so that later when you need to replace your laptop or you get a new one, you can easily restore your environment, because that's just taking too much time, and we don't have time these days. Or lastly, you write a lot of documentation and you want to share them, like READMEs or other stuff. And I think these are perfect use cases. And I'm quoting non-developer use case, so there's no software engineering tasks here associated. But Git is a perfect tool for that. Let me explain you why. So this is a table where I try to map concepts that, if you're not familiar with Git, might make sense in kind of plain English. So let's assume you want snapshots for the files that you create, for be it scripts, configuration files, or any of the above here. And basically, you want to make sure that you can always go back. You have this undo button. Yes, some IDEs or some editors give you like undo and you go back in time. But what if your machine crashes? Well, then undo is gone, right? Or what if you close your IDE? Maybe it saves the last undo steps or not. Or maybe 2 weeks later, you want to undo something that you did 2 weeks ago because you just messed totally up. So Git has this concept, or gives you this tooling, this snapshot feature, by using commits and tags. So those are things that we're going to look at. Documentation. So you want to write documentation to explain, oh, actually, why did I create this script here? Or why did I use this parameter in this way? Git, again, with commits, gives you messages that you can basically associate these commits that you produce out of Git, and say, look, I built this, like 3 files here, 2 folders there, and you create a commit out of them. And you use a message there to say, this is why I did that. So you always have not just these pointers where you can go back in time, but you also have a message of why you actually created this commit. And you maybe can say, well, yeah, let's go back to this one, or no, let's just throw it away. I don't need it anymore. So that's commit messages. This one is really powerful, the next one, virtual folders, file environments. Oftentimes we have requirements. You work in a folder, you have a couple of files there, and then you realize, oh, actually I need test files. Oh, there's a staging environment. Oh, well, let's copy stuff over here. Let's move stuff there. Oh, actually, this is a conflict here. I need to create another folder, etc., etc. We all know this mess, and so having this kind of virtual folders where you're in the same folder all the time, but you just switch these kind of contexts or environments would be neat. And Git gives you that with branches. So that's actually an example that I want to dig deeper into when we go into the demo. Backup, big one, right? You want to make sure that you get a backup of this so that if your computer blows up, you have your copy of some of this stuff. Well, Dropbox is nice, but if you have a lot of files and maybe you don't want to share it with Dropbox, Git, again, can be very helpful. And that's the concept of a remote in Git, which we also going to explore. And then lastly, tied to kind of this remote concept is, let's assume in the beginning, maybe you didn't even anticipate of sharing your code or what you're writing. But later you figure out, well, actually it makes sense to share this kind of stuff. And I want to have people maybe look at it and review it and say, look, this is pretty nice, but why did you do it this way? Let me contribute, let me fix that. And again, Git with the remotes and some of these platforms like GitHub give you these capabilities. So I think in plain English, there's a lot of stuff that we do every day and on a daily basis, even for non-developers. And they perfectly match or fit into the Git concepts and terminology. So this is not, especially in this hour that we have broken up into 2 parts, we can't cover everything in Git. And my focus here will be understanding these different concepts in Git and the terminology, so that you, once you start reading these blog posts or getting your feet wet, that you have a better understanding. But these resources here, like the Pro Git book, that's a free book online, you can read it here. It's in different languages. This is the link for the English version, but it's in different languages as well. And this link here on the right has different concepts and explains this the topics that I'm going to touch on much deeper and in a more concise way. So this is the follow-up, and I think we'll share the slides later anyways, so you get all these links here. And then yes, there's a lot of more things. And here's some guides from GitHub if you want to dig deeper. So GitHub has also a nice page where they walk you through some of these concepts, etc., etc. Those 3 last ones here, they are good helpers when things go wrong in Git and you're not sure, shall I continue or shall I just leave the mess here? Those are some nice resources when you need to fix some stuff and you don't know really how to do it, or maybe you've forgotten because maybe you don't use Git on a daily basis. And so these 3 links here are nice helpers to go back and look for assistance when things go wrong and you don't know how to resolve them. And then also some nice or useful tools, obviously terminal of your choice. Like I prefer working in a terminal, especially for explaining these concepts here with Git, because once you get the essence, you can use any UI later, any UI tool, but because you have an understanding and you know what to click in the UI, or if there's something not there that you have to go, you can go back in the terminal and do some advanced options which might not be offered in the UI. I use VS Code as my editor, and it has some very good Git support. There's a couple of extensions that I'm going to use. I don't know if you have time to show them all, but there's Git Lens, which gives you deep inspection on some of these commits, who created them, who like some annotations, etc. There's Git Blame, Git Graph, very useful tools there as extensions for VS Code. There's Markdown Preview for GitHub. So if you're writing these Markdown files to create documentation, VS Code has a default extension like integrated for Markdowns, but this one actually renders as GitHub. So if you publish stuff on GitHub, this gives you a GitHub experience here. And then I have a theme installed from GitHub, which looks pretty nice. And then there's GitHub pull request if you need to manage this on on your project, or you want to get involved a little bit deeper. All right, so there was a lot of talking. Let's actually dive into the demo. And for that, I wanted to start with the drawing board. So just give me a sec. All right, so I want to run through an example later in the terminal, but in order to better understand what's going on, let me just explain you Git basically in simple terms and the concepts that we are going to use. So when you have a folder, you can create or you can initialize that folder with a Git as a Git directory, basically. So Git starts tracking. Oh, there's a question coming in. So I like to do scripting. Can I utilize this? How to check GitHub open projects specific to technology? Okay, so the first part of the question, exactly. So we will actually have an example on this. If you just do, like, you write scripts, Bash, Python, whatever scripts, Git is perfect for you. And I'm going to explain why. The last part of the question, how to check GitHub open projects specific to the technology. I don't really understand this question. Maybe you can just rephrase, and then I'm going to get back to this one. So let's assume, or think of Git in a way as a timeline, a stream of information. Let's put it that way. And when you start, and you basically, let's say we start here with a directory, and then we initialize this directory with Git init, Git starts tracking this our directory for changes. And changes is basically on files. And then you will see a little .git folder where Git stores all the internal information to start tracking and managing these files. And now let's assume we have a use case. And this was actually a use case that I discussed with a colleague of mine, Tom, where Tom said, look, I have a lot of configuration files that I need to manage, like Kubernetes clusters. And some of these configuration files are actually conflicting each other. Some of them are not related at all. And some of them basically built on top of each other. So let's assume we have like a core configuration file where we store information for our Kubernetes cluster. And then we have some settings, maybe for specific applications, which might be for testing or might be for production, different environments. And we want to make sure that we can put them all in the same folder. But since they might conflict because of names, and we don't want to make like .test or .prod, we need this concept of virtual folders. And that's what I'm going to explain you here as an example. So either think of it that you have a script or configuration files or software project, doesn't matter, concept is the same. Let's start with this. Let's say we have our file core conf, right? And this is let's say this is a JSON file, and we have all the properties in here, and we want to use this file to configure our core Kubernetes or whatever core platform or script. Then you say, look, this looks pretty nice. Now I want to tell Git, hey, Git, can you please start tracking this? Because Git doesn't automatically track these files. You need to tell Git, hey, please start tracking this file for changes. And you say git add. We will see that later. And what Git does then, it's basically starting to track this file. It's kind of marking it in a way. And you say git add this file at this moment in time to a specific area. This is called the staging area in Git. That's a little detail that you don't have to worry about. But once you're good with these changes on your file, then you say, look, now Git, I want to commit this information into my project, into my Git project. And when I say Git project, I'm not talking about GitHub, I'm not talking about GitLab, I'm talking locally on your machine. This is still everything locally. There's no remotes involved here, nothing fancy GitHub. This is purely on your local machine, just for the sake of having Git to help you with your daily tasks. So once we commit, what Git will do, it will create a commit and maybe also a message. You can give it a message, or you should give it a message, at least a title, to explain what this is all about. You can have multiple files in there, multiple folders like nested structures, etc. In this case, we just have one file, we commit it, and then Git gives us this very long ID. It's an SHA key where they kind of sign it and make sure that it's kind of tamper-proof in this case. So we get this Git commit, and from there on, it's persisted in history, basically on Git. Unless you like to delete this whole folder, it will be there, and you can build on top of this. Okay, so we have our core conf file, Git knows about it, and it's committed. Let's assume we make a change to core conf. It's very late. We had a lot of beer. We go to sleep. And tomorrow we come back and say, oh man, what did I do there? Actually, that's a lot of mess. Maybe we even rebooted the machine and there's no way to do undo in our IDE. And that's, we just want to go back. And this is the power of Git. The first power is where I can say, look, even though I modified this file, please give me back the version that I had from yesterday or whenever this commit was created. And if you had multiple commits on them, you can even go back in time and say, look, give me the first version of this file or the second version, etc. So we can do a reset or even a checkout to check out a file from a specific commit. That's the first kind of powerful undo button. Okay. So now let's say we are good with our core commit file, and now we want to build on top of this. So we have our core configuration file, which we want to use for testing and production. But now we also have configuration files which are just for testing or for production. So we want to keep them separate. But we don't want to start like .prod, .test. We don't want to have this mess. Now what we can do is we can create these virtual folders, or as in Git terminology, we can say branch. We can create a branch. Now, in Git, there's this concept of a pointer, at which point in the Git history, oh, yeah, Kripa, question here. I'm still meaning to share the iPad because I want to make sure that we cover some of the basics, and then I'll go over to the terminal. Cool. So Git has this concept of a head, and this sounds like a weird name, but just think of it as like a pointer of where in the history of Git you are actually working on. This is literally just a pointer. They could have also called it pointer, or here I am, something like that, like you are here, basically. When you create a branch, Git uses this position of your head where you are, which is basically right now, we are on this commit, even though we have changes on this one, but our head is still on this commit because Git doesn't really know the changes that you're currently doing. They are not committed yet. So that's why your head, your pointer is still on this commit. And now you say, oh, actually, I want to create a separate timeline, if you will, which we want to call prod. And that's the Git branch way of doing things. This looks exactly the same. So when you do Git branch or Git checkout, if you want, you get a new branch. Because the branch is pointing to the same head, we're still here at this position. We are basically in the same state. There's nothing different. But if we now start adding files, like say prod config or whatever, you can even say just conf and we say commit, then, so let's say we commit here, then we get a new commit, some long string here, and our head now moves here. Our pointer, you are here, basically. And this is where things now start diverging, meaning we are now in the prod branch, not in the default branch anymore. And default is usually called master, but since we want to avoid like these kind of words, these days people start using main as their kind of main branch or tree. But just recall master, prod, whatever you call these branches, they have no specific meaning. So even master, even though it's usually the first branch or the default branch that's created, it has no specific meaning. It's just, it happened to be called master. If you want to call it main or default today, totally fine. And like, there's no difference for that. Okay, so we moved our head. Head is gone here. Now we are on a different head, which is on prod. We are on the prod branch now. And if you have your terminal set up in a way that it will show you where you are, like in which branch, it will now switch from master to prod. Okay, now we are on prod. Now we got the new task, and someone comes in and say, look, prod is nice, but we need to set up a new staging environment. And well, it's nice, the configuration file that you have in prod is nice, but we need to get rid of them because we have some conflicts. And actually, we want to build on the core conf, but for our staging. Okay, so now you have the task of basically going back to this, like moving your head back in time on this commit message, the earlier one that we created for core conf. And from there, you create another branch, which you call staging. You said staging. Okay, so we do a git checkout, which means we check out the master or main branch. That means we move here. We are here now. And from there, we do another checkout and say, create a new branch called staging. And so our head now moves into this red one here. That's our head now. It's again at the same position like we were before on this commit here. So we have an empty folder, and we don't see this information that is on prod. This is now gone because remember we have this kind of virtual folder concept. Yes, Kripa, I don't have this mouse pointer here on my iPad. I'm trying to highlight to make it a little bit better, so you can better follow. So we are not here anymore in this branch. That means these files and photos will be hidden. They are still there, but they will be hidden. Git is kind of hiding them from us if we move back to other branches. So Git is basically doing this kind of virtual environments for us. That's cool because now we don't have a file conflict. If we now create another file here in our new branch and we call it conf, that's totally fine because there's no conflict. That file doesn't exist in this branch. And if we now commit this file, here we get a new ID, right? So that's our commit here. Then we have committed our new folder file conf, which is now here in this new commit. So we'll see this in the demo as we go through, but I want to make sure that you understand that these kind of branches, even when they called master, they are nothing special. Think of them like virtual environments, and wherever your head is, and now when we commit, basically our head moves here, and it's gone from here, you will see that timeline where your current head is. That means you will see this file, you will see whatever was here, plus you will see whatever is here, and maybe what was there before. And one last word before we go into the terminal, because that's important. Obviously, it can happen that your master or main branch also moves forward. Maybe there's someone working on this, and they keep committing into this time. And this is where your branches start not necessarily diverging, but they get stale or outdated because their history, their timeline is still fixed coming from here, from where you branched out of it. And if you want to make sure that, for example, you want to update this core file here, you want to update and say, hey, now I have a, let's say, version 2 of my core file, and all of my improvements, staging and prod, they should use this new file. Then you need to move these core pointers where they come from. This one here needs to be moved up, and that's what we call as a rebase. So let's assume we want to move here to this middle one. This is our version 2 here in the middle. That means this commit here should be moved there. So, and that's what we call a rebase. It's nothing but moving our pointers, our history of pointers, on top of here. And so what happens at the end of the day is that we don't have this history anymore, like this, where we came from. The commit is still there, obviously, but our history, our pointer now, is from here. We just basically updated our root pointer or where we came from our branch. That means all the files that are in master or in main now have this version 2 of the core configuration file. Our files which are in staging, the stuff that we added, like the conf file or the prod conf or whatever, They are still retained, but they're just updated by whatever is in the other branch that we're based on. Now, the obvious question is, what happens if there's a conflict? What if someone in this main branch also creates a file called conf with different content? Well, that's now where we get into this merge conflicts, where Git will tell us, look, I don't know what to do. Should I keep the changes from the main branch or use your changes or merge them? And gives you helpful tools to do these merges. So hopefully, even though like the SketchUp looks a little bit weird here, hopefully this was a little bit clearer for these different terminologies on rebasing, branching, timelines, history, and commits. Think of these commits just as like these sealed units of changes that you want to make, one or multiple files, for example. And then you have these branches which give you this virtual folder experience. And usually we use branches for if we want to develop a feature in a specific environment. We want to say, branch here out, I develop my feature, and then I give it back to the main branch. Or if you have these different environments where you say, I have a prod and a staging environment, you can switch between them and Git will do the magic for you. All right, let's stop here and go to the terminal. This one is here. All right, so I have a folder here. I got a couple of files in here, basically mimicking that, hey, we have some files already there, but we don't have a Git. Even though this says GitHub here, this is not the folder I was talking about. Let me know if this is too small. Just ping me on chat if it's too small and people can't read it, then I'll increase it here. What we now want to do is we want to initialize this folder with a Git or as a Git folder. And we just say Git init. Now, what we see here is, hey, we have a new folder, Git. And we don't have time to go into this. Just look, like if you want to just look in this folder, what's in there, there's configuration files and all the stuff that Git needs to start tracking a folder. You will also see me using abbreviations like GST or glogger, for example. I have my shell set up in a way that I have all these aliases for these Git commands. So there's a Git command, git log, graph, very long command, and I can just do git log all, like glogger. If I want to do a git status to see what I'm currently working on and all the stuff, I just do git st, which is short for git status. Same for git checkout, gco, etc. So if you see me using these short versions, think of them as the kind of the full commands here. Those are just aliases. Okay, so when I do a git status now, Git says, hey, you're on branch master, so I use the default. There's no commits, you just initialized, and you have a lot of untracked files. I don't know what to do with them. I'm not going to touch them. Please tell me that I should be tracking or stop tracking them. This is the git add feature, okay? And what we want to do is, maybe as an example, let's say I have a couple of files. Actually, let's stop the core conf. This is the core configuration file that we want. And then I have my VS Code here, and we say version is 1.0. Just plain, right? Well, let's probably make it a bit proper here. Some quotes around. Okay, so this is our core conf file. Going back to the terminal, the status, Git doesn't know anything, we didn't tell it. Okay, now if we say git add, and then this file, core conf, Git is now starting to track this file. And you'll see this in the status. It says, oh, there's some stuff that Michael asked me to track, so let's start working on this file. Nothing happened, no commit yet. We can still modify this file. But let's say we are good with this file, right? Now we can do a git commit, and we can give it a message and also sign it. So I usually sign my commits, and you have like who created this commit. It's a good practice. -s is for signing. And then you can give it a message. You can also open an editor and give it like a full message and all the details why you did something. Here we just want to do a simple one. It's like create or add core conf. And lots of people ask, like, what is a good commit message? What makes a good commit message? And there's, if you Google around like git commit message best practices, you will find some guidelines there. Usually you start with the verb in the like present tense, it's like add, and then what you did. Short, usually 80 characters, not more here. Okay, now we have our first commit. And if we do the git log, which gives us this history, we see, oh, there's actually one commit that Michael created. The head, our pointer, here we are, is on master on this commit. That's where we are currently. Okay, now I said we need to create this production environment, right? So we want to do git checkout, and we want to say create a new branch and call it prod. This is our production environment. If I do a graph, again, to see like the history timeline, and you will see more coming here, I'll show you in a bit more visually. you will see that now we have this prod thing here, which is a branch. For Git, it's just a reference. Doesn't really mean anything to Git, like specifically. But here it's a branch called prod, and our pointer, our head, here we are, is on prod, not on master. But since they are at the same commit, they are at the same level. Okay. So let's now create a prod.conf. Go into our IDE. We have our prod.conf here, and we want to say the app is important, whatever. The environment is prod. Okay. So doing a git status again. Git, we didn't change the core conf. That's why it's everything fine. Prod is untracked because we didn't tell Git to track this file. Okay, so let's add prod.conf. Git status, we see, hey, Git knows about this new file, and we're going to commit it and say add prod.conf. So what you will see now is, going back into my IDE, I have this little tool called Git graph, where it starts building up this timeline. This is the timeline that you saw earlier, that I created. And it's a little bit hard to read. You can also see it in the command line. But in order to understand this, it's basically, we have a clean timeline, clean history from prod. Prod came from, it has an ancestor of master. That's why you see these dots, those two dots here. And our head, here we are, is on prod, and we are at prod.conf. Okay, all good so far. Now we want to go back and say from core or from master, we also want to create the staging. If we create it from here, from this prod in time, we have all the stuff that is in prod that we don't want. So what we do is we check out the previous one. You can use it as a dash, or you can also give it a name. You check out master. And then we have our files here, but what you will see is prod is gone. Because prod is a thread file for Git in the production branch. We are in master. It wasn't present in master, so Git is gonna not remove it, but just hide it for us. It's still there, don't worry, but people start sweating, oh, where's my stuff? Because we switched branches. But this is cool because we now want to go to staging. So we do git checkout, new branch, staging. If we do a git log again, we will see that head, here we are, is staging master. So we are not at the prod level because we wanted to go back to master. We want to build on the core conf file. And now we can add our, actually we can even add the prod conf. Let's do this. Assembling this kind of, it's staging, but it's still a production environment configuration file. Let's do it again. So we have our prod file, that's here. And we had app important, but environment is staging. Right, so the file name is the same, and we don't have any conflicts here. So let's tell Git to add this file, prod.conf here, git commit add prod.conf to staging, just to be a little bit more explicit here. Okay, so if we go now into our graph, we see that our histories have a little bit diverged. They still have this common ancestor coming from master, from core, but prod is not the same as staging, obviously, because we went back in time, we did modify something. And now prod and staging have two different kind of views or environments, which is cool because we're using the same file there, but even the files have different contents. Now let's go back to master and say, let's bump up the version of our file. So where is that? Core conf is here. You see prod is gone again, right? Let's say now we have version 2. So Git now will tell us, look, there's a file that I'm tracking, which is core conf, but it has been modified. What do you want to do with it? Here we've got a couple of options. We can go, like, let's assume, Michael, you had a lot of beer, and there was just crap what it did. You want to wipe out everything. We can check out the previous file. I can say git check out this file, and then I can give it a pointer or a head and say, look, from the previous commit, or from the commit before, or even from a different branch, if that file is there. And then Git will basically restore that information from history. It's almost like a backup, or let's say it's a snapshot, because a backup would be like on a different machine. But in this case, it was a good change, and we want to add it, and then we give it a message and say bump core version to 2. Okay, let's look at our graph again. And now things are a little bit starting to get messy, and this is where people then start struggling with, oh, looks like I have some stuff messed up here. Master is here, staging prod is there. I actually don't know what to do now. Well, if the requirement is now to bump up all of our prod and staging branches to pick up the latest one, because let's just go into the prod branch, and if I do a cut on core, it's on version 1, because that is where our history started from, right? But we now want to bump up all of our branches because core is being shared between these branches, and we want to make sure that prod and staging now use the updated core conf file. And this is where the rebase comes into the game. If we say rebase our current branch where we are in prod onto, well, not onto, but against master, then what Git will do is it will move our current position. So let's go back here. Prod is here, going back to this one. It will move it up to where master is, which is here. Okay, let's do this. Now let's look at what our core conf file looks now. Oh, actually it's bumped up. It's now version 2 because we rebased and we got all the new information. And you will see now that prod's history is now starting from this master commit, which is the bump core version to 2. Staging is still on the old one. And here you can do experiments and say like, oh, well, actually we would probably have started with staging first and then prod. So I did it wrong in the wrong order. But you get the point here is you can start experimenting, running your tests or whatever. And if they're all good, you're bumping up prod, not what I did. I basically am a case experiment here. I'm doing prod first. And if that goes well, I'm bumping up staging. So that was a little bit out of order. Okay, so those are a little bit the basics that I wanted to cover. What we haven't covered yet is contributing to an open source project. Those are more like just the basics, right? Getting you excited or convinced that Git is actually useful, even if you're not contributing to open source or you don't work on GitHub every day. So I hope that this little experiment here, especially explaining how these histories and commits and stuff works with these branches, have a little bit convinced you that Git can be used for these kind of tasks like snapshotting, virtual folders, undos, redos, whatever. Okay, let's leave this as is for now, and let's go to another example. So there's a project that I'm working on together with William Lamb and a couple of other very nice people. It's called the vCenter Event Broker Appliance. And just a short plug, vCenter Event Broker Appliance, or the VMware Event Broker Appliance. The repo is called vCenter because it's how it started out. The VMware Event Broker Appliance is basically taking events from your infrastructure, from a VMware infrastructure, and then forwarding that to code that you write. And you can then trigger actions, automation, just on events. So you don't have to do all the API stuff against vCenter, for example, if you want to just send a Slack notification when a VM gets powered on. All you need to know is about, hey, there's an event, VM gets powered on, and then you get triggered and your code gets executed. There's a lot of more details here. This session is not about VMware Event Broker Appliance. But we have a lot of contributors already on this project. And a lot of people there were new to Git when they started contributing. And you saw Patrick's messages like fixing the mess. I'm just closing everything out here. And so there was a lot of things that we learned together and trying to help people to embrace like these projects and help and contribute, but lowering the bar of entry for contribution. So what we did, and this is like you will see in most open source projects, there's a contributing section usually where they tell you, if you want to contribute to this project, here are some guidelines. And these guidelines are helpful for you as a contributor, but also for the people maintaining these projects. Because oftentimes you download the stuff from the internet, from an open source project, you figure out there's a bug, some issue, you start fixing the bug, you send it over, and then someone says, look, thank you for the fix, but actually we already fixed that, or that's not how we intend to fix that thing. You forgot this one, or that's not with our policy, blah, 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 blah. So there are always these guidelines, and usually they start with, you should read them, and then you open an issue on GitHub or GitLab or whatever tool you use to manage these kind of projects. And you create a ticket issue, new issue here, and then usually a template comes up and says, is this a bug report or is this a feature enhancement? Well, let's say we had a bug. And then there's this template oftentimes where you just fill out all the stuff, and then people get assigned, and then you start explaining what's wrong, and maybe, hey, I'm happy to contribute. Would you mind getting a fix from me? And then oftentimes, especially me, is like, yeah, totally, contribution is welcome. And so you start working on this. And the question is like, how do you start working on this? Like, what are you going to do? You don't have write access to this repository, right? You you actually need a copy of this one to do the fix. You can't just write your stuff here. So this is now the Git workflow for contributing, and I want to get into that a little bit deeper. So the first thing usually that you do, depending on the guidelines, but that's the common way, is to fork the fork project. Here's a little fork button on the right, which is nothing but it creates a copy of this project in your own GitHub account. So when I click fork here, Git is probably telling me, yeah, you've already forked this thing. It's already there because I'm working on this one and I follow the same approach. So I have my fork. So see, this is my GitHub handle here, and it's the name of the repo is the same, but it's not the original, right? It's kind of the fork. Think of it as a copy. This is good because if you mess up stuff here in your own copy, it's not going to impact the original one, right? And this is also important for the workflow that then follows for contributing your patch or bug fix that you do. Okay, let's go back to our code session and run this example here. So I have a repo created to mimic this workflow of contributing a little bit, and it's called Code Power Session, and I'm gonna check it out or check it out on my local machine with this command. All right. No such relative. Yeah, of course. Good. Oh yeah. So what we're gonna do is we are gonna add this remote. That's called a remote in Git terminology. It's a remote repository, if you will. We want to add it to our local repository because this is critical now. Everything that we've done so far, all the timelines that you've seen, were just local on this machine. Git, like GitHub, doesn't know about it. And Git is different than GitHub. GitHub is a platform using Git under the covers of GitHub, Git APIs. But Git is not GitHub. That's what people usually confuse. So what we now want to do is we want to contribute our code that we have written here to this project. And in order to do so, we need to add it to our local repository here. We could do a Git clone, we could do a Git fork. There's a couple of tools or UI tools to do this, but I want to do it on the command line with this remote command because that's helpful for one reason. If you clone a repository, if you do just Git clone, what will happen is you will get a name of this repository called origin. And let me actually share this with you. Let's just go into a temp folder for now. Let's clone this one. Okay, we're just cloning the vCenter event broker appliance just so you see what I mean. And we go in here. Hold on. Yep. All right. And if I do list my remotes, it will say origin. Well, what is origin? Well, okay, we can look into it. It's almost like this master thing. What is master? What is origin? Okay, in this case, origin is the VMware samples vCenter event broker appliance. We know that we don't have write access to it, right? And that's why I usually add these remotes, in this case, not with this name or origin. I add them with this git remote add command instead of cloning them. You can still clone and then change these names from origin to something else. But using this kind of git remote command, git remote add command, I can actually give it a name. And in our case, we wanted to work on this power session, not on the vCenter event broker appliance, but I wanted to just show you, because this was an initialized repository and we got the origin here. This one is not initialized yet. I want to add this remote repository as the name upstream. Okay, let's do it again. Git remote show. Now it's called upstream. I could have even called it like Michael GitHub or GitHub something. So just so this is more clear now. Why is it important? If we call git log, we will see everything local, plus now also these remotes. Right now you don't see these remotes because we haven't fetched the information from there. So now I can say git fetch everything from upstream. So get all the history from this upstream thing and get a graph again. There's nothing in this upstream, so you don't see anything here. If we go into this vCenter event broker appliance and check the graph here, there's a lot of stuff in here. Right? There's a lot of stuff. Okay, let's go back. So we are in our code session again, and we have our remote edit, git remote show. Upstream is there. Now what we want to do is we want to push our changes to this repository. Now we want to basically link our local changes with the yet to initialize remote version, which is empty, right? There's nothing here. And now we have the option to push just a branch or all of the branches, whatever we want. What I want to do is I want to check out my master branch where we have the call file. And I want to now push the local master branch to the remote upstream code power session repo. So I can do git push, and now Git's going to tell me where would I push, right? I need to know where should I be pushing to. You can have multiple of these remotes and upstreams. So I need to tell Git where to push. Okay, git push upstream. And now Git's going to tell us, okay, upstream is nice, but do you want to link the local master branch with the upstream branch? Because think of the copy or this code power session repo on GitHub as yet another Git folder, which has its own branches, if any. So Git is really treating them separately. And if you want to track them, like say like the local master is supposed to be synchronized with the remote master or different branches, then you need to tell Git to start tracking this. And once you do, then later you can just do git push because Git knows that you want to track these changes. Okay, so I'm now pushing everything locally into master. And if I reload this page here, I have my core conf there, right? So now they are in sync. And if we look here, we just have our master branch. What if I also want to push the prod or share my staging environment with someone else? Okay, git checkout prod. We do git push now. Git's going to tell us again where to push. I don't know where to push. Well, we want to push to upstream. Then it's going to say again, look, I know upstream, but which branch do you want me to track? Shall I create a prod branch there on the other one? Because that's not existing. Yes, please do so. All right, it's going to push again. All right, and now it says, hey, look, here's a new branch. And I can even look in here if I reload this page. It's showing me these new branches. So what Git now does for us, it links these remotes, like this repository here, with the local changes. And with this command, the git remote add command, what I have done is here, I've created one remote. Now, you can create multiple of these remotes. For example, you can create one remote for the vCenter event broker appliance for the one that that I shared with you, like in the VM for samples repository that is read-only for you. But you can also create a remote for your fork. And the problem is this, if you just start cloning, you will have origin or origin. And Git will tell you, look, there's a lot of conflicts because origin and origin conflicts. I don't know what to do. So that's where you usually start working with these remotes and say, look, there's an upstream or a default or a read-only or whatever. And you give it the full repository. And then you say git remote add fork, and you give it the other repository. And then you can tell Git, oh, actually, I want to push to fork, and then you want to synchronize there, et cetera, et cetera. Or you want to push to multiple of your copies, et cetera. So remotes are an important concept, and you should start using this kind of git remote command for adding and managing these remotes, because by default, they're going to call it origin. And as with master, origin is arbitrary. It doesn't say anything. And you will easily get this confused if this git graph now starts showing origin master, well, which one? From the fork or from the other one? By using these names here, you know, oh, that's actually upstream. That's the one that, or the read only or whatever. And then you will also see other branches here, which will say, look, this is going to be the fork one. And that's how you better manage. And why I'm explaining that to you in the UI, in those UI tools, it's often not clear, and you often don't have control about how to name these remotes. So this is something that probably you want to use on the command line, and then maybe in the UI leverage these branches and remotes that you have, but you want to create them with this command on the command line. You can also do this like afterwards. You clone first, and then you rename these remotes. There's a git remote rename command where you say, hey, actually, I just cloned this, and I want to call it fork, or I want to call it upstream. You can easily do this, and then Git starts showing these new names here instead of origin, because origin is arbitrary. And we had people messing up kind of some of our history because they thought they were pushing to the fork origin, but actually they were pushing to the real origin that was not intended. Okay, we covered remotes. So just briefly, Git now offers you this option, whether it's you're contributing to an open source project or to your own one. When you push a branch to a repository, Git says, look, do you want to compare this with another branch and open a pull request? Well, in fact, yes, I do want to open a pull request. What is a pull request? A pull request for Git is, or in GitHub, is a workflow where you can say, I'm opening this fix or feature up for others to review, to look at, so that before putting that into my repository here, we look over it, we debate, and we fix some kind of stuff. And then only then we merge. So this is now going to be a pull request. And a pull request, like an issue, is something that people can debate and work on. It's not yet merged. It's still kind of here. GitHub says it's still open. It's not there in the master or main branch. But if I want to merge that now into my master branch, because I say, oh, that's actually a good change, that should be part of master, I can now say merge pull request, and it will be merged into master. So Git will tell you where, and by default, it's picking master as a target to merge. In open source projects, usually people have like development or other branches where you commit to, but this is part of their contribution guideline. Okay, let's merge this pull request. Then Git creates a commit for us. And now in master, so let's go back to our view. We are in master. Now we also have the prod conf. Maybe that's not what we wanted, right? Maybe we wanted to keep them separate. But for this remote, we wanted to share it and put it in one folder so people can now start picking this kind of stuff. So this was the pull request workflow, pull request using branches. So if you contribute to open source projects, don't do it on the master branch, or don't do it on origin. Create your fork, name it as like explicitly fork, so you know where you're going to push to, like git push fork and not git push origin. And then start working on branches, feature branches, or bug fix branches, or PR branches, whatever you want to call it. Maybe sometimes people give you numbers which you should put in your stuff. Okay, so we covered branching. We covered a little bit on pull request. Note again, there's Git and there's GitHub. We don't have time to cover both. We don't have time to cover GitHub pull requests or even GitLab merge requests, etc. Those are different concepts for these platforms, but they go back to these fundamentals and basic of using Git, where you have Git branches with checkout, you have Git commits, you have Git remotes, where you start tracking and adding this kind of stuff. I could even add another remote here for my GitLab pipeline. Maybe I want to push something internally to GitLab and some other stuff I want to open source and put it on GitHub. So I can totally do that. Okay, so I'm looking at the time. We've got a couple of more minutes, and I wanted to cover GitHub Actions a little bit more. And let me or Kripa or the code team know if this is kind of useful, but maybe it was a little bit too fast and you want to better understand of how to work with this kind of stuff, then we can make it like a dedicated additional session on Git and covering more of the basics, go a little bit slower about these concepts. So this was meant to be kind of a teaser to get everyone excited about Git. All right, so we covered this. GitHub Actions. GitHub Actions is something that I wanted to share with you because it's very, very powerful, even for your daily job. So we covered kind of Git basics for why you want to use it, maybe for scripts and other environments. But GitHub Actions takes this to the next level. So what is GitHub Actions? GitHub Actions is a workflow engine. And I'm assuming here, maybe you already have a GitHub project and you want to automate some stuff there. Or you're working with containers and Docker and you build a lot of containers locally on your machine. You have this repetitive task of like creating a container, pushing it up to Docker, etc., maybe running tests, etc. Or you have other tasks of things that you automate. GitHub Actions lets you do this, where you can automate all these workflows, even very complex workflows, with a simple YAML structure and ready-to-use actions that GitHub and the community give us. And I have two examples for you here. In the PowerPoint that we're going to share, I've got a couple of resources of getting started with GitHub Actions and all the stuff. This is something you can read later. I'm going to discuss and share this with you. There's a lot of stuff that you want to know about GitHub Actions. Like what are these GitHub Actions valid to run? So it's a virtual machine that is under GitHub Actions, and these virtual machines are for Mac, Windows, and Linux. So you can actually run any arbitrary software on these kind of GitHub Actions hosts. And if you want, you can even run them locally in your environment. GitHub has a software where you can link this up. I'm going to show you this in a bit. And then there's a couple of tools and extensions, again, for Visual Studio and for local testing. They are also listed here. And maybe we'll do a deeper dive later on GitHub Actions if that's interesting for you. All right, let's jump in. Let's go back to our code power session. All right, so let's assume this repo is getting a lot of tractions. People start contributing, people start opening issues, etc. What we want maybe is that for the first, if someone opens an issue, a bug report or a feature request for the first time, we want to send them a greeting and say, thank you very much for opening or considering our project. This can be done with GitHub Actions. And if you open a GitHub repository or account, you should have automatically that be enabled GitHub Actions in your account. And it's free. It's free. Like there's a couple of tiers that GitHub offers to you, but for most of the stuff that you work with, that should be totally sufficient using the free tier there. Okay, so GitHub Actions has this concept of workflow, which is nothing but a step-by-step description of things to do. And there's ready-to-use workflows that you can use, like Terraform stuff, if you want to deploy stuff on AWS, or if you're a programmer, like lots of stuff there, Docker stuff, we're going to cover this. But then also a greeting section. So let's add this to our repo and say everyone opening up an issue or a pull request, we want to greet them automatically. So let's start with this simple action. Okay, so GitHub gives us this nice, like, integrated experience. I don't even have to open my IDE and do stuff like there. And let me zoom this a little bit in. And this is the .github folder that you saw earlier, where GitHub creates these workflows. So these workflows are now stored in the .github folder. Okay, so you give it a name. This will be displayed later. Greetings from code, we can say. And then you say on which event this should be triggered. And we say on every pull request event or issues event. And you can go much deeper. You can say on every issue that is opened or closed, or pull request which is created or closed or whatever. Like this list can go on. You see this is an array here. You can give multiple of these changes. And then there's this concept of a job. And a job is then what actually runs on these GitHub runners. And these runners are, as I said, virtual machines running in the Microsoft or GitHub environment. Or you can run them locally on your environment, and you just install a little agent where GitHub sends signals or like work to this agent if you have more like security concerns there around that. But ultimately, these jobs are being executed. And then each job gets a name. So we can have multiple jobs here. And if we specify multiple of them, they will run in parallel. And there's a couple of limits that GitHub imposes on these free accounts here, but like they are totally fine for the free tier. And then you say, what is the operating system that you want to run on? And you can say Ubuntu latest. There's a huge list of different Linux flavors, Windows flavors, Mac OS flavors that you can pick here. And each of these virtual machines, you get a fresh one, like every tenant or GitHub user gets its own kind of sandbox virtual machine. There's plenty of tools installed in these runners. And that is very useful. So you don't have to install stuff. Usually, you will find it already being present. For example, Docker is there. They even have Kubernetes in there. And we use that a lot in vCenter, in the VMware Event Broker appliance, because what we do is we run automatic tests against our code. And we want to make sure that our code runs with Kubernetes, for example, and the functions that we build there. And GitHub Actions gives us a Kubernetes kind of cluster. It's called Kubernetes in Docker. So it's kind of a local cluster, but still it's kind of Kubernetes. And so you can even run Kubernetes inside these actions here. We don't have time to cover this today, but like the software that is installed here is like crazy. And in one of the links that I showed you on the PowerPoint that we'll share later, I have a link to all the software that is installed in these runners. And obviously they are different from Windows to Mac to Linux. A lot of stuff in there. And then you have the steps, and the steps are basically per job sequentially executed. And in this case, we just have one step, which says we want to use like an existing action. It's called first interaction. And then you can give it some parameters. And in order to write to your repository to basically add a command to an issue, it needs a secret. And this is automatically injected by GitHub with this GitHub token. You don't have to do anything. I don't have to set up anything there. And then for issue message and PR message, we can say, well, we can give it a message. And I think I have something already here. So for the issue message, let's use this one. Thank you for bringing this to our attention. We'll shortly look into this. And then for PRs, if someone opens a PR and wants to contribute to our project, then we say, hooray, we're excited about your first contribution. That's it. Now we can say, where's my start? Oh, here, start commit. Again, GitHub forces us to use the git commit workflow. So we now have a file which we now need to add to Git. And we commit this file. And now it's part of our master branch. It's called GitHub greetings in the GitHub folder. So for now, nothing happens. So if we go to the Actions tab, greetings from code, nothing happens because we haven't created an issue yet. So let's create an issue. New issue that this is buggy. I don't like this. Not a very helpful and probably not a very good issue to start with, though most people were gonna ignore this one. But what now happens is, since we created an issue, an event was fired, and this new issue event is being picked up by GitHub Actions. And you can see GitHub Actions has a workflow. Well, we can go in here, but we under all workflows, we see all workflows running. And if we click into here, it's basically telling you why it was triggered. Oh, it's greetings from code on issues. Okay, let's go in here and check what's going on. And so GitHub now goes through all these steps that we had in there. So it's gonna set up the job. That basically that's creating the virtual machine, making sure that everything is safe and secure, and now starting the action. And it's gonna write something. It's already done. So how long does that take? 30 seconds. If we go back to our issue, we have the bot which says, "Thank you for bringing this to our attention. We'll shortly look into this." Okay, so this is a very simple example of using GitHub Actions for greetings. Now, maybe you're into containers, or you work a lot of with containers, you build containers, you want to share containers, etc. So what I have here is I created a little program which spins up a little, it's a Go program, which just spins up a web server, and you can call the web server and give it a parameter, and then we'll greet you back. Nothing fancy, not production ready, but just for the sake of showing something here. So now we have the situation. So let's go back to master. We have the situation that our master branch has evolved, right? It's kind of further ahead in the history. So our head is older, our local master is older than the upstream master. Okay, how can we fix that? Well, we learned rebase. We can now rebase onto the upstream, or since we are tracking this upstream master, like this one follows the upstream master, we can also say just pull in everything from the remote branch. This is basically kind of similar than like the rebase. We just pull it from the remote. But now GitHub is actually telling us, oh, hold on, there's an error because you created this greetings file on the remote on the here. We just committed it, right? So it was a commit. But I also had it locally, and Git said, I need to stop here. I don't know what to do. I don't want to mess up your work. And it gives you this error message. And this is where people usually start struggling. Oh, I messed up. I need to delete everything. But let's clean this stuff manually. So there's a Git configuration option called merge tool, and you can set it. And merge tool is basically telling Git, hey, whenever these kind of conflicts come, use this tool, this merge tool. And I set it to using VS Code. Okay, so Git basically already said that the files are the same, so there's nothing that we need to do here. In this case, actually, I can just go forward. If there was a real merge conflict, let's assume that my that this remote workflow was different, the message was different, then Git would have given me two of these files, which I now could evolve. But since they are the same, basically, it's telling me there's nothing that I can do here. And now I can say I git pull force and just move my pointer there. Oh, still not happy. It's because it's local. Yeah, let's remove this kind of stuff. Let's remove everything, do the git pull, and then we should be good because the file is not there. Yes, perfect. So now we have everything up to date, right? So we are on master, upstream master, they are the same. That's good because we wanted that. And now we want to add another workflow because we want to create our Docker container for the HTTP server that I just showed you in this main file. So what I have prepared is I have a main Go file and I have a Docker file. Let me just quickly add them to our history. Oh, packages gone. Where is it? Just give me a sec. I deleted my package folder. Obviously, the live demo guides are not with me here. So we can, yeah, let's do it live. Let's do it live. And we'll be done in 5 minutes. So we'll be going a little bit over GitHub, Docker, action, build push action. We're going to use this one. And we can, yeah, this looks good. So we can set up a new workflow. Actions, new workflow. Where's Docker? Docker. I thought I saw it somewhere here. Oh, we can search for it, I think. Just give me a sec. Deploy example usage. Yeah. So let's lose this one here. Create a new workflow. Set up a workflow yourself. Name, create Docker image. And let's say on every push, yeah, I think that's fine. On push, whenever we push to our repository, let's build a container. So let's add this here. So, just some indentation, YAML. Is it happy now? Not happy with indentation. So, and let's go here. Probably the YAML indentation, that's not right. Let me copy from here again. One more. The width is here. That was the problem. Still not happy? Did you mean if? No, I did not mean if. Users with, what am I doing wrong here? Do I have a backup of this? Just let me check, please. I might have it somewhere here. Oh yeah, here. There we go. So let's go back. All right, we're back in business. So, and the repository is called creator push to Docker. Yeah, this is all good. So now what we have here is we want to push to Docker, create a container image. And here we want to say on every push, on push. Job push to registry using Docker is a red 0, so that looks good. Start commit. So our action is ready. And now it's waiting. Okay, now let's push our stuff. So we have, let's fetch it in. Fetch upstream. So we go. And then code, session, upstream, pull. Perfect. So, and now we're going to push our stuff up. Git add main, Docker file. We're going to say we have our stuff, Docker file, push it up. So what now happens is that GitHub Actions will look for, yeah, it was looking in here because there was no Docker file. But now it's checking, hey, there's a new Docker file in this repo. And now I'm going to do push. So usually what you do instead of push, you basically say on every release or so, whenever you want to do that. But now that we have our Docker file in there, we start. So Docker is checking this container out, check out the repo. It's now pushing to Docker. It's building the container. Da, 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 da. Give it a couple of seconds. Meanwhile, I can go to my Docker account to show you what's happening. Still pushing, 30 seconds. It's building. It will also add labels, which is nice. So you get some more information on these containers when it pushes it. All right. All good. Job completed. If we go to Docker Hub, we will see that the latest tag is updated a few seconds ago. Latest few seconds ago. The other ones that I had here, they are a little bit older. And if we are going to do Docker run creator, it runs the creator. And if we curl the creator now, so this is using the image that we just built, and we give it a name. Hey, Michael, nice to meet you. So what you can also do is with this action is you can push it to different registries. If you have, for example, have your private registry, your Harbor, your GitHub package, etc. So this is very, very neat. And there's a couple of tons of other workflows specific to automation, development, Docker, etc., Terraform, and even Kubernetes. So GitHub Actions is very, very powerful. And I hope we can do a dedicated session on GitHub Actions in this case. So this wraps up our demos. There was a lot of stuff we covered. Maybe it was a little bit too fast. Please let us know in the feedback. We can do a dedicated session deeper on Git. Maybe there's some questions open. I'm still looking at the chat, no further questions. So please let us know, give us feedback, things that we can do better, maybe dedicated sessions or more on GitHub Actions, because unfortunately we didn't have so much time. Thanks for watching, listening, even for the recording if you watch it later, and hope to see you soon and in another episode of our Code Power Sessions. Thank you very much.